Okay, so here's some good coding. For me, it's good practice. For you, it's good observation. So you can learn a little bit about coding here. So, and so I'm putting into MATLAB the ideas that I introduced in the last video of how we're going to filter the pupil data. So here there's this clean filtering we've already done of the data. This is the section of the code where I take the entire column of pupil data, like from our little Excel sheet here. All the pupil data are shown here in column J. So not just for one trial, but for all 80,000 rows or whatever it is across all 40 trials. All those data are here. They're pup size. Pup size is a variable where I just went into the Excel file and said, take that whole row and make it a variable called pup size. So that's what pup size is all the pupil data. And then I tried to make this other variable called pup size clean, which I did by saying if pup size is less than 1 or it's greater than 100, make that little cell in pup size equal to nan. Otherwise, just leave it the way it was. And that's a cleaned set of the pup size data. Basically, pup size data where we threw out all the zeros or numbers that were like 1,000 or some crazy number that it couldn't be real. So now we're going to just add to this and throw out more pupil data based on the stuff I talked about in the last video. So first thing we need to do is create a velocity variable. So for a equals 1 to length of pup size, we're going to say vel pup vel. I'm calling it the velocity of the pupil, which doesn't really make sense, but velocity of change. Pup vel sub a equals pup size a minus pup size a minus 1. So this a is just the number row we're on in the variable. So a pup size a minus pup size a minus 1. That will be the velocity, just like we did in the Excel sheet. I probably didn't explain it very well, but you might have seen me do it quickly. So that will be the pup velocity of this row in A. Now I know we're going to get an error because the first, when A is equal to 1, there is no 0th row. So it's going to throw an error because A minus 1 is going to be, A is 1, so we're going to have pup size sub 0. There is no pup size sub 0. So what we have to do is create an if statement for that and say if A equals to 1, pup vel A equals 0. We'll just give it a velocity of 0 if it's the first frame. And then we'll say else, then we set our pup vel to that. So now we have a velocity. So then we can say if blah, 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 pup vel sub a is greater than, let's just say 5 for now. Or pup size sub a is less than negative 5. Pup size clean a equals nan. Else if. So I'm making another reason to throw it out. So then we say else if. No else if. If ends there. If ends there. Why is it angry with me? There's some, this is red here, that means there's an error. See the little red dash here. if I click on the parse error line 154. Am I supposed to put a space? Oh, I think it's just supposed to be on the same line, that whole conditional statement. Yeah, okay, that's what it was. Okay. So now I've done the velocity chucking. I think if I run this, it should get rid of all the ones, all the frames that have a velocity change in pupil size above 5 or minus 5. What I'm going to do now, though, is say pup average equals mean pup size clean omit man's pup standard deviation equals standard deviation pup size clean omit man, and then now I can create a new if statement if inequality for a equals 1 to length, just like above, pup size, and I'll say if pup size clean sub a is what, greater than pup average plus 3 times pup standard deviation, or pup size clean sub a is less than pup average minus 3 times pup standard deviation. Then I say pup size clean equals nan. Sorry, I got caught on a tangent and my silly brain is struggling. So there's an error in this prior for loop. I got distracted, but so let's finish this. Here. Oh yeah, maybe that's the reason they were still. And then we say, okay, yeah, right. So I think we can just copy the code from the other one. That's why I ended up looking. So for that, if this is that, then we will make it nan, else we'll just keep it the way it was. And then we end that. Boom, got rid of the error. Okay, I think we just did. So theoretically, now when I run the program, we should get our little graphs for subject 474 should be so beautiful that they contain no artifacts for the pupil size. Let's see if we did it. Taking bets. Who thinks we did it? Oh boy, I forgot. forgot to put a semicolon somewhere, and so it's printing out all this stuff. I'm going to have to stop it. It's going to take a minute. Or did I not put a semicolon? There. Try it again. Okay, one graph came up, the XY position data graph. No, the pupil graph just came up on the other screen. You couldn't see it, but it looks like it's not fixed. I wonder if I'm just graphing the pup size data, size, and not the pup size clean variable. Let's check. T pup. Oh, it is. Yeah, it's not graphing the cleaned data. It's graphing the raw data. Okay. Okay, let me figure out how to fix that offline, and I'll show you.